Hello, welcome to our video solution to problem 6 from Superquiz 2. This one is going to look a lot more complicated than it is. This is really more of a conceptual understanding of how the Euclidean algorithm works. So the Euclidean algorithm, right, is going to repeatedly use the division algorithm. So we might start with an A and a B, and we say, well, okay, A is equal to QB plus R. And we know, of course, R is less than B, Q and R are non-negative integers, et cetera, et cetera. But then how would we proceed in the Euclidean algorithm? Well, we would slide the B and the R over. And we say, okay, fine. So B is going to equal some maybe Q1 times R plus another remainder R1, right? Where again, R now is going to be less, R1 is going to be less than R. And well, if we like, Q1 is still going to be some non-negative integer. Okay, and then we would continue, right? We would shift the R and the R1 over. So we get R is equal to, say, some Q2 times R1, and there again might be some remainder R2, where again now Q2 is going to be some non-negative integer, and R2 is going to be less than R1. Okay, and we keep going. And at some point, we might get to say where, well, let's see, we have like some Rn minus 2 is equal to, well, let's see. Let's see, well, actually, let's write down one more. It'll help with the indexing, right? So if we slid over, we'd have R1, and we'd have R2, and then this would be a Q3, and then R3, and you'd see, oh, look, the index 1, 3, so we got to go up by 2. So this would be Q sub n. And then this is one more than the one here, so this will be Rn minus 1. And then the Q's and the R's here match, so this will be R sub n. Right? And of course, the next step, like this could be the last step before you actually have divisibility. So maybe you have Rn minus 1 equals Qn plus 1 times Rn, right? Plus a 0. And this is either a 1 or something not 1. Either way, you get the greatest common divisor. All right? And so the Euclidean algorithm tells you, right? So we know that the proof from Euclid says that Rn is equal to the greatest common divisor of A and B. Okay, now what are we trying to show in this problem? Well, we want to show that the GCD of A and B, which we just established as R sub n, is the same thing as the GCD of B and R. Well, where do B and R come into the game? Well, in step 1, okay, there's your B and your R. But in step 2, you notice they take on the role of A and B from step 1. In fact, what one could do is just completely ignore this top step. You can just say, well, I have B and R, and I want to know their GCD, so I apply the Euclidean algorithm. And everything would proceed in exactly the same way. So the Euclidean algorithm, I'll just call it the EA, would proceed in the exact same way, starting from BR rather than AB. And so we get the exact same remainder in the last step, R sub n. Okay, so since the last non-zero remainder, non-zero remainder is still R sub n, we have that the GCD of BR is equal to R sub n, which we already knew was the GCD of A and B.